So I have this study. I have a few studies. This one is from 2017, I want to say. What year? Doesn't say the year, does it? I'm sure I could find it. Anyway, I don't think it's that old. So, an empirical study of design degradation, how software projects get worse over time. Context. Software decay is a key concern for large, long-lived software projects. Systems degrade over time as design and implementation compromises and exceptions pile up. Goal, quantify it. Method, we constructed an empirical study on the presence and evolution of code smells used as an indicator of design degradation in 220 open source projects. Now, I can already tell you that there are some issues with just looking at this by itself and using it to make a deterministic statement that software is in decline. However, this is just one of several factors that kind of piece together the whole argument. The best approach to maintain the quality of a project is to spend time reducing both software defects, which is bugs, and design issues, which is refactoring. We found that design issues are frequently ignored in favor of fixing defects. We also found that design issues have a higher chance of being fixed in the early stages of a project, and that efforts to correct these stall as projects mature and the code base grows, leading to a buildup of problems. So essentially, the end result here that they've discovered is most things that tend to get fixed fall into the defects category, not the design issue refactoring category. From studying a large set of open source projects, our research suggests that while core contributors tend to fix design issues more often than non-core contributors, there is no difference once the relative quantity of commits is accounted for. We also show that design issues tend to build up over time. And I think this is the real killer here, is that it goes back to what we were talking about before, which is the silent killer, where you have bugs or issues that go unnoticed until time. It's a time-based issue. And you don't know what those are because you're not focused on those things. Software systems require constant modifications in the form of bug fixes and the addition of new features to satisfy end user needs. Failure to do so might lead to losing users or unsatisfied users. The pressure to keep growing and evolving the software makes it impossible to refactor and redesign when a requirement changes. This, I think, was a good. I'm not going to read everything in here, but this was good because I think this is actually representative of what happens in the real world. I think we've all been there where in the real world you work at a company, and by the time that you get to a point where you realize that a design, not necessarily a bug, a design issue is causing you a huge pain, the cost to change that design it's too late. You're not going to be able to get the company as a whole to be convinced to spend the time to fix it, right? This eventually leads to decay in the software design and the growth of technical debt. One outcome of such decay is that code becomes more difficult to extend or understand, and as a result, the ability to evolve an application tends to decrease over time. I mean, like, in general, regardless of like some of the specificities in this study, I think this is very true. Like, this is what happens just generally. How many of us have not seen this happen in our like day-to-day what would you call it, employment, right? Like, I think about all the companies you've worked at, whether you're a junior developer watching right now or you've been around the block for like 50 years. How many times has this paragraph happened in a company where you rush towards something and you kind of ignore some of like the things that you kind of know you shouldn't be ignoring, and then by the time you always think, oh, we'll have time to fix it later, and then when it rears its head, it's too late, right? It's too late. And good luck getting the company to be like, all right, well, I guess we're just going to have to buckle down and we're going to have to fix it, and it's going to take a huge refactor, but here we go, and then it's too late, right? Or here's another thing. I'm kind of what would you say? I'm kind of spoiling a little bit of a spoiler alert. Companies that have the ability to refactor refactor and actually don't solve anything. They actually make things worse. The refactoring makes things worse. And I have some studies that actually, like, they don't, like, I'm not going to say they prove it, but they're pretty damning, evidence that, like, it's not as great as you think it is, even if you have the ability to refactor. Oh, and I see you, man. I'm not watching chat 100%, but I see you. Thank you for gifting that sub over to Laugh. Laugh, I guess you're my child. Or I guess you're a child of Owen. That's what I mean. You're a child of Owen. And he's paying his child support. Thank you, Owen. I appreciate it, man. You're awesome. You did not have to do that, man. You don't pay support, you're adopted, yeah. Omni says, problem when things work out, nobody writes about it. So, Omni, I think think that's fair, but I'm betting that once all this data and some of the data that we've seen already gets all put together, the data shows that constantly increasing problems in general means that things are not getting better, even if they do work out. So even if you have some undeterminate amount of projects that work out just fine, there's an entire general state that's showing itself on a trend of not working out. And you can even externalize. I haven't shown the data for this. It's going to come in a few streams, I guess, at this point. But there is data that is kind of like metadata. So it would be something like overall data to show the number of defects on websites and apps and software as a whole when compared against consumer satisfaction. And you can actually see it was the same thing as we saw with like the CVE report. Something happened where those numbers just took like a huge nosedive. And it was not a small amount where you could kind of offset with like, okay, but maybe there's like unreported good stuff. And, there's just a little bit of variability in the negative stuff. And that goes the most reported. And yeah, sure. But there's just something about the last 5 to 10 years. Things just went like really, really bad. So I do think you're right. I do think that the stuff that works out doesn't get reported anywhere near as much. But I'm not sure that entirely negates the argument. But we'll see. We'll see as I go through it. Okay, so we kind of get the point here. In this paper, we represent the results of an empirical study on the presence and evolution of code smells used as an indicator of design degradation. To the best of our knowledge, in contrast to previous studies, ours is the largest study so far in terms of both the size of programs involved, so 534 to 100,000 lines, and the number of projects analyzed, 220 open source projects. This allows for stronger and more widely applicable conclusions about the evolution of design degradation and code smells. So the goal of the study is to shed light on how design degradation happens as a project ages and how traditional quality assurance activities contribute or fail to contribute towards improving design quality. More specifically, we try to answer the following research question: how code smells evolve over time? Is refactoring aimed at addressing technical debt dominated by specific subgroups of developers? Does the testedness of a project and the quality of tests show a correlation with design quality? Is there a match between the smells discussed in literature and in tools and the smells projects most commonly struggle with? So then they talk about, free and open source and etc. They talk about related work, such as previous studies and statistics that have been done, where code smell comes from, introduced by Fowler. Code smells are symptoms of problems in source code and indicators of where refactoring is needed. So the distinction is that code smells are defined at a higher level of abstraction and have a negative impact on a larger part of the software value than a localized piece of code. Code smells have been associated with bugs and code maintainability problems. Now, I feel like code smells is just a bit too abstracted, but I think what they've done in this study is good enough in that they've kind of determined where like a clear delineation when there's like a code smell equals a design issue versus a bug. And if you can clearly identify that there's a code issue or a bug, I don't feel like it falls under code smell territory anymore. I think you've pretty definitively like nailed down what the problem is, and that's why I think this study is like a good one, because think what you will of code smells in an abstracted sense, but what they essentially did was they said, well, there's kind of two things going on here. There's bugs, and then there's design issues, and so they kind of like looked at both of those. The methodology. So they're talking about like how they chose the projects that they picked, and so then they just they did whatever they had to, and in order to determine like the project size and things like that, and how many contributors were there, and all of these things, right? So they looked at even things like number of commits, because number of commits help in terms of looking at overall size of the project and what are the commits for, and things like this, right? So they essentially just break down what they've done. So they provide some averages over all the projects that they've looked at. We chose Infusion to identify code smells because it has been found to identify the broadest set of smells. Researchers have found that the metric-based approach identified by Marinescu has the highest recall and precision for finding most code smells. Infusion uses the same principle and set of threshold for identifying code smell, which was another reason for using Infusion. So again, think what you will of code smells. I'm not really, it's code smells, but again, they did break it down into more distinct categories, which I think helps the study more than not. Okay, so damn it, more ads. Okay, I'm gonna